is spawning a process, and that was the process ID of that thing, and it's executing a module called this and entering it in a function called that. Okay? Now, of course, in order to keep track of the few named things, I also am exposing that a process is registering as this global name within that specific VM, that file server 2 is this process. And it's often true that a process registers itself as a name. So think of that register-unregister pair as really passing through to my dtrace script, a way of me hanging on to the few known points in the entire environment, and then I can go and look at all of the spawns that this guy is doing later. Okay?
Can we see, not to jump ahead, but can we see the script?
I think if I can find what I hope is the window. No harm in. Oh, there.
If you could make the font bigger too, that'd be really helpful.
Is that plausible, or is you want
One more time.
Hey, more. Just say when.
That's better.
What? There's a few lines off the top which we can pull down if we need it. So I'm simulating this little piece of the syntax. In Erlang, the middle piece is the local VM's process ID. The top piece is the VM's ID. So when you've got a few hundred or a few thousand VMs, they structure the identity so you can tell whether this is a local thing or a remote thing. That all happens by magic. So that's what all of that gubbins is. I'm just copying across from my parameters some block into the local address space so that I can print that out and give you the few bytes out of the message. So it's about as simple as humanly possible, I think. A whole pile of stuff that we could do much more nicely, I'm sure. So where are we? I know where. So if I start that guy up again. Okay. So we're sitting in the usual kind of environment that you would expect to get with any of these languages. Is the usual loop. Now inside the approach to Erlang, there's a very different model. You can think of this as an embedded model where you're not going to have a shell, and you can start this all up without bothering. Let's just start with a proxy. So my little Erlang program is now the proxy. And so if I just start up Adium, Adium is the, just one of these instant messaging guys. Never ever want to do that. And if I start a connection for him, right. Unfortunately, it happened in the background, but basically every time somebody tries to connect to that XMPP server, what I've done is really set this guy up as a teeny weeny little proxy, and so everything is going through him. And you can see what's happening here. He's registering on, they're talking to each other, and I'm just stripping off the first 40 or 50 bytes out of the TCP/IP packet. We see 1157 bytes is actually hanging out there. So inside my Erlang proxy, I could rip these packets apart and do whatever I wanted to. So if I wanted to just monitor which particular machines are going across there, I could do that. This was just the simplest thing I could think of to do something interesting with what we've got already working. So, yeah.
So how does that compare to what Ericsson, I assume they have a tracing framework at the minute in some
Yes.
variety. And has that, have you shown the Ericsson guys this and what do they think? And how does
The initial reaction from some people was, you don't need anything like this because we've got an internal tracing framework. The issue is that as soon as you go out to MySQL, or you come in from a different application, that tracing framework does you no good whatsoever. And so your whole vision of an end-to-end trace works fabulously well if you're a telephone switch, but it doesn't work very well if you want to just use dumb ordinary application technology. So they're interested if we get somewhere and we're setting it up so that this can just get folded back into the normal distribution. But we have to get far enough for them to be able to see some value.
And presumably we're seeing more and more Erlang growth in that kind of, I mean, it's been positives for a long time. We're now seeing presumably more interacting with MySQL and so on.
Oh, yeah, I mean, Amazon, was it CouchDB, just came out a few weeks ago and the whole thing's built on an Erlang platform.
Yeah.
There's a fantastic, web-wide spreadsheet system being built, paper numbers.
Kirk, you and I learned that the other night. When the Amazon revealed they built this huge system around, I had no idea that they built and deployed it. Yeah.
Yeah, I mean, there are various companies like Amazon who are putting quite a lot of wood behind that arrow, they used to say, to build stuff out of this. And so this facility gives us some way of seeing what's happening across this, but we still need, in my opinion, some way of making the data types that exist within dtrace and the data types that exist within these languages much more amenable to be able to use them without having to pile a load of extra work in or just a lot of extra CPU cycles to flatten the trace.
So Derek, briefly on that point, describe what are the operators that are interested in zero mapping, that you can sort of a C-style think about things, are there operators we can add, or just do different things?
No, I think the first level operators for me are just to be able to use the predicates. Right. So I just want equal and not equal.
Right.
I would just like to be able to say, is this atom or is this string, is this fragment that I'm expecting through part of a list? So the first n bytes are equal. And even though the thing's a list, just be able to compare it to a text structure. So I think the first pass for what we're doing, which to be fair is, a lot of it is based around this XMPP stuff. Right. We've got a socket and it's just spewing out byte sequences, and we just want to be able to chop pieces off. So, yeah. So I'm pretty much done.
Great.
What do you want to take over?
Sure. Thank you.